Okay, so to start, let's just have you do these two problems. Very simple. So on the first one, the only difference is those parentheses. And so you probably remember from your previous classes getting it drilled into you. This is negative times 2 to the fourth, like negative 1 times 2 to the fourth. So then this ends up being negative 16. Whereas this one is, if you think of it like this way, negative 2 times negative 2 times negative 2 times negative 2. That's why this one's positive 16, because there's an even number of negatives. Okay, so that's the first idea. The second thing, and I didn't type this in here, but just real quick, do you remember how to rationalize a denominator? So for example, if I gave you the fraction of 3 over the square root of 2, do you remember what it meant to rationalize the denominator? To rationalize the denominator means that we can't have any radicals in the denominator. So we want to eliminate that square root of 2. So I'm going to multiply by the square root of 2, because what that does, it gives me the square root of 4, which is just 2, right? But in the rule of fractions, whatever I do to the bottom, I have to do to the top. So if you think about this, is just like multiplying by a big 1. And so then what I end up with is 3 square roots of 2 over 2. Okay. Another one that I had forgotten about when I first revisited algebra was something like this. 5 over the cube root of 2. Now, here's the trick of this one. If you go back to the problem we just looked at, why did we multiply by the square root of 2? Well, because we got the square root of 4, right? And this, think of this as like, this is really the square root of 2 squared, so they cancel out. Okay, so here's the trick on the cube root. If we want the cube root to cancel out, then we need to do the cube root, but we have to do 2, and it needs to be squared, so that this would give us the cube root of 2 cubed, right? Because that's how your cubes are going to cancel out. Okay, so the reason why that radical goes away is because the cubing and the cube rooting, or the squaring and the square rooting, undo each other. So here, whatever I do to the bottom, I have to do to the top. So I'm going to take the cube root of 2 squared. So then that leaves me with 5 cube roots of 4 over 2. And that's how you would rationalize the denominators. For here now, we're going to talk about the fundamentals of algebra, and we're going to focus on the exponents and radicals for this lesson. So our first rule is simply the rules of exponents. So these are our rules, and I'll just give you an example of each one. So here, if I have a to the negative n equals 1 over a to the n. So for example, if I had 3 to the negative x, that's equal to 1 over 3 to the x. And letter B is the idea that you can distribute, and when you distribute, you're going to apply the first rule. So for example, if I had 4 over 5 all to the negative 6th, I would switch the denominator and numerator to accommodate the negative. So I'd have 5 to the 6th value over 4 to the 6th value. Letter C, that rule is simply anything to the 0 power is 1. So I could make something as nasty as like 3x to the 4th, y to the 3rd, but if it's all to the 0 power, then my answer is just 1. Letter D, when you multiply and they have the same bases, you're going to add the exponents. So for example, if I have 4 to the 5th times 4 to the 7th, that's going to be 4 to the 12th. Letter E, when I divide, so when I multiply, I add. So when I divide, I subtract. So for example, if I had 3 to the 5th over 3 squared, that's going to be 3 to the 3rd. Letter F, I'm going to distribute. I can multiply that in for F. And so a power to a power, you're going to multiply the exponents. So for example, 4 squared to the 3rd, then that would be 4 to the 2 times 3 is 6. So 4 to the 6th power. The next rule is like the distributive property. I always think of it, I'm just distributing that n to both things. So for example, if I had 3x all to the 5th power, then that's going to be 3 to the 5th and x to the 5th. Letter H, again, distributing basically top and bottom. So that if I had, for example, if I had 2 over 3 all to the 5th power, then following this rule, I get 2 to the 5th over 3 to the 5th. And then the radicals with fractions. So when you have a to the 1 over the n, that's the root. So for example, if I had 4 to the 1/2 power, then that's going to be equal to the square root of 4, or 2. And when you have a fraction, the top number is going to be your exponent for what you're raising the power to, and the bottom number goes to the root. So for example, if I had 3 to the 2/3, then that would be equal to the cube root of 2 squared. And then, kind of like the idea of a distributive property, you can break apart the radicals. So for example, if I had the square root of 9 times 25, I could take the square root of 9 times the square root of 25. And then finally, you can break apart the radical in a fraction. So for example, if I had the 5th root of 27 over 32, then that would be the 5th root of 27 over the 5th root of 32. So the rules of exponents, when we want to find it, when we want to calculate it, we're always going to do the root first, and then we'll raise it to the power, and then find the reciprocal when we have this. Okay, so we're going to kind of ignore the negative. We'll do the root, then we'll take the power. So for example, if I had 8 to the negative 4/3, okay, what I'm going to do is I'm going to think about the cube root of 8. So first thing I'm going to do is the cube root of 8. So the cube root of 8 is 2. Then the next step, I'm going to apply the 4th power. So I'm going to do 2 to the 4th power, which then becomes 16. And then I'm going to take into account the negative. So my answer would be 1/16. So that's mentally what I'm thinking as I'm looking at that. So the rules of exponents. When you have roots, a to the n is equal to b, then a is the nth root of b. If a squared equals b, then a is the square root of b. So it's the idea of undoing each other. They kind of work together, the root and the power. If n is positive, even integer, and a is positive, then a to the 1 over n denotes a positive real principal, a positive real nth root of a. Here's some examples. So as we look at this, we can see that here we have 4 times 2 to the negative 3rd, we know is 1 over 2 cubed. Okay, so then what I have is 4 is 2 squared over 2 cubed. So I just have 1/2. Number 2, if I distribute the negative, I'm going to use that rule from before. It's a negative exponent, so I'm going to go 3 to the 3rd over 2 to the 3rd. And I can leave it in exponential form. I don't need to evaluate any more than that. Number 3, as I look at number 3, I'm going to work with the negative exponents first. So I'm going to move the 2 to the 3rd on top. And when I move 6 squared to the bottom, I'm going to recognize that that's 2 squared times 3 squared, because 2 times 3 is still 6. And when I do that, then I can see that my 2's are going to simplify, so I'll have 2 over 3 squared. Number 4. So number 4, if I focus on the top part, if I focus on just the top part, then the top, what I have is 2 to the negative 1 is viewed as 1/2. and then I have minus 1. 3 to the negative 1, because the exponent's negative, I can move it to the top to make it become positive. So then I can take that and times it by 3. So now what I have is 1 half minus 1 is negative 1 half, times it by 3 is negative 3 halves. Number 5, I'm going to do the exponents. I'm going to work with the parentheses. So I'm going to give the 3 to each thing. So I have 3 to the third times x to the 6th, because power to power you multiply. And then I have this negative 2, and then x to the negative squared, because there's a negative exponent, that's going to go on the bottom. So now 3 to the third is 27, times 2 is 54, so I have 54 negative. And then I have x to the 6th and x squared, so that's going to be x to the 4th, because I can subtract the exponents. Here's some more examples. In dealing with the negative exponents and simplifying it, I can see that my a's, I'm going to have more on the bottom. So I have a squared on the bottom, and then b to the negative 1 is going to go to the bottom to become b to the 6th. Number 7, if I think about taking the cube root first, then I'm going to take the cube root of negative 8, which is negative 2. Then I'm going to square it to get me 4. Same thing on 27. I'm going to do the cube root of 27. That's going to give me 3. And then I'm going to take it to the negative 2 power, which 3 to the second is 9. So then this answer is 1/9. 100 to the 6/4. Okay, when I look at 6/4, do you see that is 3 over 2? So I always reduce these. It'll make your life easier. So then instead, I'm thinking about 100. I'm going to take the square root, and then I'm going to cube whatever that might be. I should put the cube out here like this if you think of it that way. So the square root of 100 is 10, and then I'm going to cube it to be 1,000. On the next one, my bases match, so I'm going to add my exponents. So I'm going to add 2/3 and 4/3. So then I have x to the 6/3, which is just x squared. Number 11, I'm going to distribute the 1/4 to each thing. So I have x to the 1 power, because 4 times 1/4 is 1. And then y to the 1/8. A couple more examples. If I look at this one, I can deal with a couple different things. If I think about just the a's, I can simplify that inside here first. So I have b to the 2/3, and then I could subtract 3/2 minus 6, so that a is negative 9/2. And then I'm going to cube the whole thing. So when I cube the top part, that's going to cancel, so I have b squared. When I cube the bottom part, I get a to the negative 27th for 2, which then would be a to the 27th halves times b squared to deal with a negative exponent. Number 13, the square root of 49 is 7. Number 14, the cube root of 1,000 is negative 10. Number 15, if I break this apart and think about just the 4th root of 16 and the 4th root of 81, I get 2 and 3. Number 16, if I deal with the cube root first, the cube root of 125 is 5, and then I can square it and get 25. Number 17, this is just having them have the same radicals, simplifying them. So then this is 2 square roots of 5 plus the square root of 5, which is simply 3 square roots of 5. And that's the end of your lesson.